Hey guys, this is Miss Van Norman. Today we're going to be talking about transformations of functions, but we'll be focusing on the x values. Just as a quick reminder, yesterday we looked at functions where we had them transformed and we did things on the outside of the function. So when I add or when I subtract something on the outside of my function, it is actually going to be a shift up or a shift down. When I multiply or divide something on the outside of my function, we would say that is a vertical stretch or vertical compression. Anything that happens on the outside of my function is going to happen to the output, which is your y values. So you might be thinking, what about things that happen on the inside of my function? Or what about stuff that affects my x values? Let's take a look at a graph in Desmos. You notice that I have this function, his name of is f of x, and he is graphed like this. We're going to see what happens when I subtract 2 on the inside of my function, and that's applied to my x values. So I'm going to subtract 2 and see what happens. Okay, once this is graphed, you'll notice that this has been shifted to the right 2. 2 makes sense because that's the number we put in our function, but the right part doesn't really make any sense. Why did it go to the right? Because when you subtract values, you would think that they would get smaller and that would be going to the left. Well, let's see what happens when we add 2. When we add 2 to my function, it looks like it has been shifted to the left 2. Again, this seems backwards because when you add, you would expect it to go to the right, to be getting bigger. But we're finding here that everything that happens on the inside is opposite. And here's why. You guys remember that a function looks like this, where I have a series of inputs and outputs. X is my input, Y is my output. Well, right now, when we're dealing with functions, this is where we are. We are in function world, and we're applying our function and we're graphing that. If I were to try to change my y values, you'll notice that I would be going this direction, and that's the same direction as my function. I'm going in order of my function. But if I went back and I tried to change my x values, that's going the wrong way. So what happens is the opposite always ends up happening because I have to undo what's happening to my x's. And we know in math that when you undo what's happening to your x's, you do the opposite. So essentially, whenever you're dealing with your x values, everything on the inside is opposite. The outside is normal, and that's going to be affecting your y values. The inside is opposite, and that is going to affect your x values. So let's look at our example. We had this picture from yesterday, and we can pull some points off of this picture. If I just pull these 3 points off the picture, I can graph those, or I can put them in my table. We have the points -4, -4, 0, 0, and 6, 6. We already said that when I transform this function by subtracting 2 on the inside, then that is going to actually shift it to the right 2. Well, in order to shift it to the right 2, I'm actually going to do the opposite, and I'm going to add 2 to all of my x values. When I do that, I end up with -4 plus 2 is -2, 0 plus 2 is 2, and 6 plus 2 is 8. There's nothing happening on the outside, so my y values are going to remain the same. And then I have these points. Let's go ahead and graph this. I have the point -2, -4. I have the point 2, 0, and the point 8, 6. Once I have those graphed, I can finish my picture. And notice that it looks exactly the same as my original. It just, all of my points are shifted over to the right 2. So again, when you subtract 2 on the inside, that is going to be a shift right 2. What would happen if we added 1 on the inside? Well, again, the inside is opposite, so this is actually going to be a shift left 1. The inside's opposite, so that's a shift left 1. Now let's take a look at multiplying and dividing. Again, we have our original graph. I'll put those same points on there. X and Y, -4, -4, 0, 0, 6, 6. And we're going to transform my function. This one is being multiplied by 2 on the inside. Okay, well, let's think this through. Everything on the inside is X values, and everything on the inside is opposite. So instead of multiplying by 2, we can actually write this one of two ways. We can either take my X value and divide it by 2, or I could write it like this, and I could take 1/2 of my X values. You guys know that if you cut something in half, you're dividing it into two pieces. So those are the same thing. So let's do that to our X values. This would be -2. 0 divided by 2 is still 0, and 6 divided by 2 is 3. My Y values are going to remain the same, so I have -4, 0, and 6. Once I graph this, I have this point here, here, and 3, 6 here. It looks like this line is actually smaller. And that's actually what happened. Imagine someone puts their hands on both sides of the line, on the right and the left hand side of the line, and they compress it, they push it together. This is what we would call a horizontal compression. All of my values have become skinnier. Okay? Not taller, but they're skinnier. So that's what happens when you multiply by 2 on the inside. It's a horizontal, it's in the X direction. Compression, it's made smaller by 2. So what would happen if we had 1/4 X? Well, because it's happening on the inside, it's still going to be horizontal. But instead of making it 1/4 the size, it's actually going to do the opposite. It's going to be 4 times the size. So this is going to be a horizontal stretch. Okay? So, just a few things to remember. Everything on the inside affects your X values, and everything on the inside is opposite. Now you guys can go ahead and complete your assignment for transformations of your X values. Thanks so much. Bye.